This is the BrainChip podcast. Hear from our thought leaders about neuromorphic computing, beneficial AI, and how BrainChip's Akita is pushing AI to the edge. This podcast is a place for investors, practitioners, and anyone interested in the future of AI.
Hi all, I'm Rob Telson, Vice President of Ecosystem and Partnerships at BrainChip. Welcome and thank you for joining our latest episode of our BrainChip podcast series. These events are structured to provide current and future investors and those interested in AI and the BrainChip technology a path to better understand who we are, what we are doing, and where we are going. If you've not listened to any of our podcasts, please go to our website, www.brainchip.com. Go to our media tab where you will find our podcasts. You can also listen to any of these podcasts on your favorite podcast platform, or please go to our YouTube channel at BrainChip Inc. and find all of our podcasts and additional media. Today, we have the pleasure of spending some time with Sally Ward Foxton. Sally is a writer for ETimes who has been writing about the electronics industry for more than a decade. As a journalist, she has published articles in ETimes, Electronic Design Europe, Microwaves and RF, ECN, IoT embedded systems, components in electronics, and many, many more. Sally has become one of the most recognized voices in journalism in regards to communicating on the evolution of AI. Most importantly, always highlighting the latest technology introductions and trends. Sally, welcome to the BrainChip podcast.
Thank you so much for having me on the show. I'm delighted to be here.
Well, I have to be very straightforward, Sally. I'm really excited about today's podcast. I truly admire your work, and so it's really great to have you with us today. For our listeners, I've had the opportunity to speak with Sally a few times over the past year as BrainChip introduced our development kits, our PCI board program, and in regards to our activity with some of our key customers. And beyond our discussions, Sally has been the voice of the AI community and has written about specifically neuromorphic computing and its adoption as part of the evolution of AI, especially when we talk about all the new introductions at the edge. So, Sally, why don't you take a moment and provide our listeners with a bit of background on yourself and what you are currently focused on?
Yeah, absolutely. So when you read out my bio just now and you said, I've been writing about the electronics industry for more than a decade, it's actually closer to 2 decades now. So I guess maybe I should update that. I've been with the ETimes for about 5 years. I'm writing about AI accelerators, specifically on AI chips for about 3 years now. So I kind of feel like I came in on the ground floor when I was assigned that beat. I really fell on my feet, let's say. Before that, I was a freelance journalist for a lot of years, but always kind of in electronics and semiconductors. So yeah, I've been around for a little while. As we're saying, today I'm writing about AI chip companies from NVIDIA, from Intel, to the many, many, many startups that have sprung up in the last few years in this space. It's a very exciting space to be in.
Yeah, I have to tell you, it's again, because you had that experience in learning and understanding what a lot of these companies are doing and their messaging and where they want to go. You have this view, this inside look that a lot of us don't have when you get to sit down with all of us and hear our stories and our plans and what we're doing. But let's dive into AI. Let's talk about the differences that you see between what is happening at the edge and what is happening at the cloud. We have a lot of people that really don't understand that the AI engines and what we're doing. There's some that are designed for the cloud, some that are designed for the edge. So why don't you give us your view on that?
So when we say cloud, to start with, there's cloud and there's cloud. Like there's public cloud or there's just data center in general. A lot of enterprise data centers springing up now all over the place within companies. But there's also more like HPC, scientific computing, and supercomputing, which is its own separate niche. But we focus on kind of more like public cloud and hyperscaler kind of workloads. Right now, I think for chips, for AI accelerators, there are a few players. What we have in this space is hyperscalers making their own chips. which has always been a thing. And I think 3 years ago, there was some question as to whether they would continue doing that beyond a couple of generations, or whether NVIDIA would be able to persuade them out of it. But so far, Google's still working on its TPU. They're on V4. We have the Chinese hyperscalers as well working on their own chips. Maybe they have their own reasons, which is maybe not part of this discussion, but Amazon, of course, AWS are also working on their own ARM-based chips for AI acceleration. So yeah, aside from that, we also have, of course, NVIDIA, very, very big in the cloud space, very, very big in this data center market. And they really are the one to beat right now, as I think, probably everybody listening to this already knows. I do want to say that we do still have a very large proportion of data center workloads, especially in hyperscalers, running on CPUs as well. So Intel Xeon CPUs are absolutely the market leader for data center CPUs. And it could be that data centers haven't changed over to AI accelerators just yet. Maybe they're still in the process of refreshing the hardware or doing that. Or maybe they want to retain some flexibility in their infrastructure. But we mustn't forget that a lot of data center AI is still done on CPUs today, a fact that Intel likes to remind us about. Of course, we have a whole bunch of startups making big chips to go into the data center for this very specialized environment. We have Cerebras, we have Sambonova, we have Grok, we have Untether, we have TensTorrent, we have GraphCore. We have a few other more specialized offerings for particular data center workloads like Esperanto and new chips focused on recommendation. But what we're seeing so far is they're still trying to get a foothold, I think, in these very big installations. So yeah, it's a very different picture to what we're seeing at the edge, where there are many players, big players, small players, and many different kinds of niches. In the cloud, it's still like big chips, big NVIDIA, big Intel, and then let's try and take some from them. It's kind of with the edges the other way around, right?
Yeah, and I think that one of the things that for our listeners, Sally made a really good point. When you think of the companies that she's highlighted, they're developing, I call them big engines. And these big engines are designed to process a lot of data. And with that, they're going to consume a lot of energy. And they have, right now, they have the benefit to be able to do that. As time goes on and architectures change and demands change, we'll see some of this adjust a bit. And you'll probably see some of the guys that have developed some of these smaller, more efficient processors start to almost follow what ARM did, where they started with these small, very efficient processors and started developing around that and increasing their technology capability to the point where, as you mentioned, you'll start to see ARM in server and so on. But so that was great. Thank you. Let's focus on edge-based AI and let's talk about what you believe and what you see as some of the key drivers in this space, as well as some of the problems that you feel need to be addressed over the next few years.
Absolutely. So the edge market, I mean, it depends, again, how you define edge, right? There's edge and there's edge. So if you are from the data center side of things, when you say edge, you just mean somewhere outside the data center. Still could be very, very meaty, very big hardware, right? But then all the way down to, what's in your consumer electronics and what's at your sensor nodes, your IoT nodes. Maybe we call that endpoint AI sometimes, but edge is certainly a spectrum. Chip-wise, it's quite fragmented right now because there are so many different niches. There are so many different applications that all have very slightly different requirements. So there's a lot of space for startups to kind of push in here, try and own particular niches. We're seeing a few spring up that are more specialized, let's say. But in terms of drivers at the edge, yeah, it's the opposite. It's the opposite to the data center. We're talking about power consumption. Number one, right? Ultra low power consumption, depending on the power envelope of the application. We may be talking about latency, depending on, again, the application. If it's something that is responding in real time, then of course you need very super fast latency. There are other requirements in terms of like how much flexibility do you need in your workload? Are you only doing computer vision on this chip, or are you also doing audio in a consumer device? Like you need obviously some kind of hardware that can cope with those different types of workloads. So yeah, it depends on the niche. It depends on the exactly where on the edge you are and what your requirements of your application are, and what kind of hardware you're going to select.
Yeah, you're spot on. And so you see a lot of different, as you say, niche, I say specialty technology, where, look, I'm going to focus on, let's say, voice, and others are going to say, I'm going to come in and focus on vision, and so on. So you're right. There are very few that can handle and be flexible enough to address voice, vision, vibration, and smell, and so on. That's one of the key buzz things that I highlight about BrainChip's technology, just for a plug there. But the fact that there's some flexibility in what you do. But okay, so one of the things that we get excited about is the introduction and some momentum, especially this year in regards to neuromorphic computing at the edge. And now we're talking, for our listeners, we're talking the edge of the edge. So we're really talking efficient computing. And what makes this interesting is that there's just a lot of dynamics of where you go from there. So what I was curious about, Sally, is when we talk about neuromorphic, and you've had the opportunity to write about this from a lot of different perspectives, what makes this interesting to you? And in your opinion, what are the key technology advancements for the design community leveraging neuromorphic computing? So you've gotten to hear a lot of different stories and where companies are going with this architecture. But if you had to filter all that, I mean, what would be your thoughts on neuromorphic computing and where it's going?
So from my perspective, as a person who writes about AI chips, that's my full-time job, is to study and write about AI chips, right? This is super, super cool. What a super cool story to have a chip that can behave like the brain, right? Or is inspired by the brain. But again, I feel like a broken record here. It depends what you mean by neuromorphic. I know I think neuromorphic means kind of brain inspired in inverted commas, but do we mean specifically spiking accelerators, or do we mean, anything which is running deep learning, which you can say is vaguely like brain inspired by some types of brains? Like, again, there is a spectrum of some are more directly brain inspired than others. There's a lot of debate out there about, how closely should we copy the brain? We have to consider the limits of silicon as the medium. Can we directly copy or should we be directly copying what happens in the brain? Is that a good idea? I think there are several companies, including BrainChip, that are making a good go of it, have products that work and showing that there are advantages to be had by using these kind of spiking architectures and spiking accelerators. I think, it's in some cases, not everyone is as far along the roadmap as BrainChip is. There are a few others also in this spiking space that are working on different architectures, whether it's asynchronous digital like BrainChip and Intel, or whether that is analog, like fully analog, like your actual brain is completely analog, and of course there's even more power can be saved if you can do it that way. So I think some of these are unanswered questions, shall we say. There are also some unanswered questions about how do we train spiking networks, stuff like that. A few challenges still left to be ironed out on that side. But overall, I'm very excited for synergy between spiking processors, spiking accelerators, and other like brain-inspired sensors, like event-based sensors, event-based cameras. I think there can be synergies there, which is super exciting. Probably a lot of fun to write about. How well will this work in the real world? I'm not so sure, but for my purposes, it makes a great story, right? But ultimately, it's like, do we even understand 100% how the brain works? And if we can learn more about the brain and build better computers, then it's a great story for me. So absolutely, right behind it.
I think your last statement there is right on. I think we're at the forefront of all this. We're learning as we're going, and one of the things we've experienced is is when at BrainChip, when we designed our first chip, we got our silicon back. We had specific areas, specific markets that we thought this technology would really apply to. And very quickly, we were able to start pushing the limits of what the silicon could do. And a lot of that is dependent upon the ability to get networks, the ability to have the right data behind it to make those things happen. But you're spot on. I mean, there's going to be so much that we can do with the architectures. Will it ever mimic the human brain 100%? Is that a good thing? I think those are really good questions we have to ask ourselves. For the time being, we have some applications and the ability to actually make products better in regards to what we're trying to do as consumers, and even looking beyond into like medical devices and other areas where it's really going to enable us to do better things in the short term. So yeah, we'll start there.
It's a bit like, does it even matter how closely brain is like, depends on how much of a purist you are. Does it even matter how closely it mimics the brain if it works better than technology we've already got? So yeah, I think you can be too much of a purist on this side. You've got to make a commercial product out of it as well, of course. So yeah,
That's
some of the things we're talking about are scientific, like still in the research community, and some of the things we're talking about are here in the commercial world. And I think that's a very valid distinction to make.
Yeah, exactly. And that actually leads into our next question. Let's talk about the future. And you wrote an article, I think it was in the October timeframe, that captured my attention, highlighting transformer networks. And these are, for our listeners, these are big, beefy networks. And these networks traditionally have to be supported by really, as I call them, big engines. So this goes back to how we started this conversation at the hyperscaler level. But including the transformer networks, what are some of the key movements that we as technologists and we as consumers and so on should all pay attention to from your perspective, and why are these impactful?
So when I wrote that piece on transformers a few weeks ago, it's like you can't go anywhere without seeing the word transformer. It's like transformers here, transformers there. A lot of research is heading down this path of transformers. Transformers started out in natural language processing. So this is the kind of network you're probably thinking about that is understanding language, reading these vast resources of language and somehow creating text from it, or somehow as if it's understanding language. Whether it really understands it or not is maybe a little outside the scope of today, but one thing everybody knows about transformers is they're absolutely huge. We're talking about like GPT-3, millions and millions of dollars, months and months to train, and that's to train one network one time. These are really staggering proportions, and not really relevant to like BrainChip and what BrainChip does. But what we are starting to see now is smaller transformers that can be used on the edge, like VIT, which is vision-based transformers. Yeah, and kind of spreading to other applications outside of natural language processing. So I think this architecture has basically become so powerful. It's like now they're kind of taking over a little bit, as we say. So it's a bit like if all AI workloads head towards transformers, everything kind of converges on this one type of workload, which would be super, super easy then for chip companies to just make a transformer accelerator.
Right.
But on the other hand, it's like, are we ignoring other research paths that we should be going down by putting all of our eggs in one basket? So yeah, transformers, were relevant only for the data center, for the biggest chips that we were talking about, the big engines, but becoming more relevant at the edge, and will become more relevant, I think, in the months to come. Yeah,
I think you said that very well, and it's something that we should all pay attention to in the near future. At least my gut says that. So, all right. So let's change gears a little bit. Let's talk a little bit about ETimes. Tell us what are some of the exciting things happening, and for our listeners and those that are very serious about AI, do you guys have any events or other activities our listeners should be paying attention to?
Thank you for the lead in. If you're listening to this podcast and you're interested in the kind of topics we've been talking about here, you should definitely look out for our AI virtual conference. It's called the AI Everywhere Forum, December 13th to 15th, although if you're listening after that date, you can catch it on demand. We have tracks on chips and AI chip design, on AI systems and system design, and then at the software and kind of model and data level as well. We have some great speakers, industry experts and academics, different kinds of people. It's going to be very, very interesting, as well as companies. So yeah, go ahead and check it out at aieverywhere.eetimes.com. Yeah,
it's a good event. It's an event that we participated in last year. And the positive thing is, as Sally mentioned, it is virtual. So for all of us around the world and at your own pace, you can access the content and really learn a lot from it.
Yeah, absolutely. It's free to register. All you have to do is sign up, and then you can watch the content whenever you're ready.
Yep. So here at BrainChip, we like to focus on beneficial AI. It's going with the theme that we've had today. We'd like to just make sure, let's not lose sight of what we're really trying to accomplish here, which is this is good technology and make the world a better place. How do we do that? So this is, we think about, okay, what are some of the impactful things that will help us in our lifetime? And if you look at beneficial AI and you think of it from that perspective, what do you see as one area where AI will impact us in a positive way?
So absolutely have to say scientific computing in general. If you can teach AI the laws of physics, you can fight climate change, you can search for new drugs, you can make a COVID vaccine. There's so much that you can do. I think within that, to focus on just one area, almost every aspect of medicine and healthcare is going to get accelerated a ton. All the way from research, like let's discover some new drugs, develop some new drugs to fight diseases, to the transformers that we were talking about earlier, doing natural language processing. Let's feed it loads of medical journals and try and have it look for drug side effects in those journals, or feed it doctor's notes. There's a lot of medical data out there that we could potentially make more use of with AI. Right down to like hospital equipment. Let's build an MRI machine that we can wheel around and bring it to the patient's bedside. There's a company called Hyperfine that does this, and the AI corrects for the low quality sensor. It basically corrects the noisy image, so it can use lower field strength and lower quality sensor. It's super, super cool, and enabling all different kinds of applications. So maybe you have, I don't know, an ultrasound machine that helps the sonographer take the measurements by understanding what it's seeing what the machine is seeing in the image, and giving the sonographer tips on where to go and what to do. Right down to the edge, medical wearables that can monitor us. I mean, we already have our fitness trackers and things, but these are going to get much more sophisticated, I think, be able to kind of monitor us and alert us to any changes. You can use AI on a small scale to look at patterns, understand the results, and do that in the device without a cloud connection and within a battery-powered device. So yeah, every aspect of medicine, I think, is ready for acceleration.
Yeah, you hit on two fronts. You spent a lot of time talking about medicine and the types of applications that AI will enhance, and I agree with you wholeheartedly that this is really an area where when we start to have the capabilities and the technology all refined, it's going to accelerate our ability to predict, analyze, and address medical dynamics from all different aspects in our personal lives, and also in regards to when we really need compute to help us solve a situation. The other one you mentioned at the beginning was really climate, and I think AI is going to help us from. I had someone on a while ago that talked about farming and talked about the ability to take the technological advancements that we're doing on the edge and apply that to his ability to do better farming, and which will provide more food more efficiently and be able to adjust as weather changes in the different environments and the behaviors of the animals and so on. So there are some really, really interesting areas where we're going to be able to make our world a better place as we continue to advance technology. So, okay, lastly, I like to close on this question. I think it's really important for our listeners to understand who we are beyond just talking about what we do in our daily lives. But if you could be one superhero, who would it be and why?
So this is definitely the toughest question that you've asked so far, especially not really being a superhero kind of gal. I was going to say Batman, but I think actually who I really want to be is Bruce Wayne. It'd be really super cool to just be this kind of benevolent tech billionaire, be able to like influence the tech industry to the extent that you can influence the way technology is going and, you know, just be really powerful without actually having to be magical. That would be cool.
I love it. That's a good one. That's a really good one. Okay, Sally, I want to thank you for spending the time with us today and providing your feedback and your insight. It's truly appreciated, and on behalf of our listeners, I know they're really going to enjoy this discussion. On behalf of the BrainChip team, we want to thank all of our listeners, customers, future customers, employees, investors, analysts, and everyone interested in learning more about AI and BrainChip. We truly appreciate all of your passion and support. For those curious, our podcast series will continue. And so until our next podcast, we wish everyone to stay healthy, happy, and most importantly, stay out of trouble.
Thanks for listening to the BrainChip podcast. Please remember to rate and review on your favorite podcast platform.